Okay, this is Algebra 2, Chapter 5 review. I'm going to kind of turn this around because we've always started with the functions and added and subtracted, and I'm going to end on that. So we're going to start this way. Find the inverse of f of x equals a negative 5x. How do you do that? Art?
Switch the f of x to y,
Okay.
and it equals negative 5. Well, no, that's totally wrong. Switch the f of x to x.
Nope, you were right.
Oh.
Now we
yeah,
switch.
that's
Now
right,
we
yeah.
interchange these, right?
Okay, yeah.
Yep, you're right. And then how do we solve this?
Solve for y.
Okay,
So divide by -5.
all right. So we rewrite it as f inverse. That's how that looks. You need to know how to write that. Equals. Can I move the negative to the top? All right.
And that's the same as -1/5 x, right?
That is correct. This and this are the same. Okay. Utan, it says determine which pair of functions are inverse functions. How do you do this one?
You just take the first one and then substitute the f of x for y again, and then switch the x and the y and solve for y.
Okay, so I could do it.
it's the
Could I take this one and put it into that?
Yeah.
And what would I get?
Same thing. Or if you get the
If I take this, if I take f of g of x, right? I would put the g into the f function, right? And I would get x plus 3 minus 3, which is what?
x.
Is that what I'm supposed to get?
Yes.
Yes, I'm supposed to get x. What if I don't get x?
It's wrong.
So then I have to turn it around also, right? And I have to put the f in the g function. So I would go x minus 3 plus 3. Do I get x also?
Yes.
So that worked out really great. It's the first one, isn't it? Okay? You do that, you could do that for each one. That's time consuming, isn't it? This is a question you might want to skip and come back to. I mean, the chances that it's the first answer, could take a while, right? Okay? All right, so we're going to go down to a graph. So I want to take a look, 3 and 4 on a graph. So let's take a look here at a graph. What is this? Is it a parabola?
It's half parabola.
It's half a parabola. So what is its parent graph?
A parabola.
No.
F of x equals square root of x.
Okay. F of x equals the square root of x. Remember that, Harper?
Yeah.
Okay, so Josie.
Jonesy.
Jazzy, sorry. I got that on video now too. You can hold that against me. Sorry. I got it. All right. F of x equals. How do I do this one?
I'm not sure.
Okay.
These ones, this is what gets me.
Okay, Greeley?
Is it square root x minus 1
Okay.
plus 2
I don't think it's x minus 1.
plus?
It's plus 1, moves it back.
Okay.
Now you said minus 2. Did it go down 2?
I said plus 2.
Okay, plus 2. Did it go up 2?
Yes.
No, this point did not go up 2. This point only slid over 1 from the origin. All right, so this is correct, except for one thing. It's wider than normal, and I think that's what's confusing you. It's supposed to go 1 over and 1 up, right? But it went over 1 and up 2.
So
There's a 2 where, Utan?
in front of the
In the front of it. Because the value's doubled. That's where the 2 comes in, Greeley.
Okay.
All right, so now let's talk about domain and range. Jaws, can you do the domain?
Is that like the negative infinity stuff, or?
Yeah, kind of. This is the x value. Where does it start?
-1.
Does it touch a -1?
Yeah.
okay? Then
And
where,
infinity.
to infinity. Now on the test, I was telling Harper about this, this will be in set builder notation also. So x is greater than or equal to a negative 1. These are the same, right? You understand that? Ooh, okay. Now the range. Now we go y. Where does it start? Addie?
0.
It starts at 0. Does it touch it? Sure does. Touches it right there, doesn't it?
Yeah.
And where does it go? As far as
Infinity.
it goes up to infinity. Once again, now the range, we don't use x for the range. What do we use?
What?
Y. Okay, so y is greater than or equal to 0. Okay, any questions on that before we switch slides?
What when we do the x for x or whatever?
Uh-huh.
When would it be less
If it went,
than? Like to
if it
negative
went
infinity?
this way,
Oh.
it would go a negative, no, it still would be, yeah, it would be, this would be x is less than or equal to a negative 1.
Okay.
Yes,
Do we
okay.
have to write this set builder notation?
It's, as I told Harper, it's a multiple choice question. So you'll choose the domain and range from multiple choice. Okay? Okay. All right. Now it says find the inverse of each function and graph both. When I say graph both, I want you to graph the original and this. So, how do I write the inverse of this? What do I do first?
So y for f of x.
Switch them and then solve for? Okay. What do you think the number one missed thing on this one?
Plus or minus.
Plus or minus. He is correct. When we take the square root of both sides, we need to make a plus or minus x minus 1. And this is the number one thing missed on it. Okay. Now when I graph this, okay, I want to graph the first one, the x squared plus 1, right? How do I graph that?
You start up 1, right?
Up 1, yes.
And then over 1, up 1, over 2, up 4.
Very good. Don't forget my arrows on the parabola. Now, I don't graph this one. We talked about this yesterday. What do?
Reflection.
Yeah, we turn these points around, right? So this one is 0, 2, so it'd be 2, 0, right? And if you want, all of them that go up go right, correct? So I can just go 1 over 1 up, just like that. We do the same thing, only sideways.
I thought it was 0, 1. To be 1, 0.
Oh,
right?
it is. I'm sorry. You're right. It's right here, isn't it?
Yeah.
Thank you. Questions? Really? All right. Okay, so next set is graph each function, state the domain and range. So we're going to graph this in a minute. Well, let's graph it now, shall we?
Yep.
While we got it. Okay, so the graph is, I'll write it on here, f of x equals the square root of x plus 2 minus 1. All right, so right like that. It's up here in the corner. Okay, so how do I do that?
Subtract 2.
I start at the origin,
Down 2.
left 2, down 1. Now, since this number is 1, Utan,
It's just normal, over 1 up 1 over 2 up 4.
over 4 up 2, right? Like
Oh.
that. Remember?
Oh, yeah.
Oh, it's just half of it?
Yeah, it's over, well, it's a square root of 4, so 1, 2, 3, 4 up 2. Okay? Can we do domain and range on here? John, as I asked you this the last time, so let's see if you learned anything. I'll let you give it an interval notation because that's the way you'll have to do this. Do you have a question, Greeley, or you know the
Isn't
answer?
that the one where you can put like x plus 2 equals 0?
No, that's solving.
That's solving?
That's solving, yeah. This is still graphing,
Okay.
okay?
So, interval notation, you said?
I want domain, yes, interval notation.
Okay, so x,
It's a bracket or parentheses.
it's a squiggly.
Well, okay, I want you to put an interval notation, not
Oh,
sub.
okay, bracket, negative 2, infinitive, parentheses,
Range,
parentheses, wait, no, it's bracket, negative 1, infinity, parentheses.
yeah. Okay?
Yep.
All right, very good. Okay, so,
Wait a minute, I got a question. So how do you know if it's only half of it or the whole thing? Because I would,
okay, that's a great question.
is it like plus or minus?
If it's plus or minus, it's the whole thing. If it's a bracket, it's only 1, okay? All right, so now this is the one that you do the solving an equation or inequality. This is the one that you need to do, correct?
Mhm.
All right, so if I ask domain and range on this, okay? If I ask domain and range, but am I asking domain and range?
No.
No. I'm asking, and so I'm asking you to solve this. How would you do that?
Subtract a negative 2.
What's that?
Subtract a negative 2 from each side, right?
Yeah. Oh, you know what? Greeley, I spoke wrong, I think. I'm gonna correct that. Let's go back to this. You can do that. I now know what you're saying. You can do that. You can go, this is what you were saying right here, right?
Mm-hmm.
You were saying this, weren't you?
Yeah.
Okay, yes. Do you know that's the same as looking at your graph and doing it?
Mm-hmm.
That's what you were saying. Okay, all right. And then you put this back in to find the range?
Yeah.
Yes, yes. You can do that on this one.
Okay.
Okay, and it's the same thing, right? This would be greater than, okay. All right, right?
Yeah.
Okay. Well, it just dawned on me what you were saying. I don't know why it took me so long to focus on that. Okay, anyway. So we would add 2 to both sides, right? Or subtract a negative 2, which is the same thing, correct? So we get 2x plus 9 is equal to 7, correct? And now what?
Square both sides.
Square both sides. We call that power up, right? And then we subtract,
9.
9.
we get 2x equals 40. So x equals
20.
20.
Oh, that's-
Okay. What about this one? That's to the 1/3 power if you can't tell. What do I do first?
Subtract.
No, add 3.
Oh.
Or 6.
Add 6 to both sides?
Mm-hmm.
Then what?
Divide by 3.
Divide by 3. And then what?
Power up to the 3rd.
Power up to the 3rd
You just get 3x.
equals,
8.
Yep.
and I'm going to add 1 to both sides.
Mm-hmm.
Yes.
3x equals 9. Divide by 3, correct? X equals 3.
Even for ones that come out really nicely like that, do you still have to put it back in and check it and stuff? Or is it-
We should be checking, yes, we should be. And you would take 49, 7 minus 2 is 5, and then this would be 9 minus 1 is 8. The cubed root of 8 is 2, 2 times 3 is 6, so they both work. What about this one? It's an inequality.
Do it the same, except just if you're multiplying or dividing by a negative, then you need to switch the inequality
Okay,
sign.
so we're going to take 3x plus 13 underneath the square root is greater than or equal to 10. Square both sides. Subtract 13. That 87.
Yeah.
Divide by 3. Now, did we divide by negative?
No.
So we keep the same sign. X is greater than or equal to.
What's 87 divided by 2?
This doesn't come out even, does it?
29.
Does it come out to 29?
Yeah.
Oh, wait, 27, yeah, okay. So I put 20, now this, you gotta be careful here, because it's, your answer's greater than 29, right?
Mhm.
So this will be equal to 5 when you put it in, but it will be, your values are greater than 29, so you go back through 87 plus 13 is 100, you know, it works, doesn't it? 10 minus 5 is 5, right? Okay. Questions? Okay. Now remember I told you we started backwards, correct? So we begin with this. And there's quite a few of these. I got 6. I think there's more than 6. So I don't know how you want to do these. Remember, you have a practice test that I gave you too. Remember that? I gave you right at the beginning, or practice review, right? Have you completed that? Okay, that would be a good thing to take home and complete. All right, so we're going to add the 2, right? On the test, there's 3 of them, but just for time's sake, I just wanted to do 2. So we're going to take 2x plus 9, which is f, plus g, which is x squared plus 2x plus 1, correct? So my answer is this is like with this, and this is like with this. So my answer is x squared plus 4x plus 10. Is that correct?
Yes.
And I leave it like that. Now this one, f is minus it, right? So I have 2x plus 9, subtract the quantity. This is the biggest mistake that is made on this particular problem, is we subtract the quantity, correct? So I have 2x plus 9, and then we bring that minus sign through everything. So it's plus a negative x squared, plus a negative 2x, plus a negative 1. So I have a negative x squared plus 8, because the 2 x's cancel. Biggest mistake on that one, and I get a lot of that. It's not like it's not common. F of g, does g go into f or does f go into g?
G goes into F.
G goes into f, so I have 2 times x
What's the last
squared.
number?
That's x.
Oh, okay.
X squared plus 2x plus 1 plus 9. So I have 2x squared plus 4x plus 2 plus 9. And I have 2x squared plus 4x plus 11. Very easy to make mistakes on these, guys. Okay? This is the hardest one because it has restrictions. One of the harder ones because it has restrictions. So if I put g, which is x squared plus 2x plus 1, and I put it over f, I must have a restriction here because I have a denominator. You understand that, Jaws?
Yeah.
So I go 2x plus 9 is equal to 0. Subtract 9 from both sides. I get 2x equals a negative 9. And then x equals a negative 9 halves. So my restriction is x cannot equal a negative 9 halves. Do you understand that?
Yeah.
Okay, several years ago I had a student that forgot that this was different than this. That's an open circle, this is a closed. This means multiplication. That means I have f, which is 2x plus 9 times x squared plus 2x plus 1. And you use the distributive property. 2x cubed plus 4x squared plus 2x plus, and we do the 9 also. 9x squared plus 18x plus 9. So I have 2x cubed plus, is it 13x squared plus 20x plus 9. Question?
Wait, where did you get that? Oh, from the first one. To the third power.
2x times x squared is 2x cubed. Alright, so now on this one, I'm going to put 5a into the g function. Then I'm going to take that answer and put it into the f function. Alright? So I'm going to put 5a in the g function, looks like this. 5a squared plus 2 times 5a plus 1. So I get 25a squared plus 10a plus 1. Now, I'm going to take all of that, I'm going to plug it into the f function. So I have f of all this, right? So I have 2 times 25a squared plus 10a plus 1 plus 9. So it all goes into x. So I end up getting 50a squared plus 20a plus 2 plus 9, which is 50a squared plus 20a plus 11. Okay, now you notice I haven't put a number in, right? I didn't know if we'd have time for this or not, but we do have time.
Number.
Yeah, in other words, what number am I on? 16?
Yeah.
Okay, so I'm going to use those same ones, right?
Oh.
I'm going to go 16. I want, let's go g of f of a negative 2. Okay? All right, so I put a negative 2 into the f function, right?
Yep.
So I have a negative 4 plus 9, I get a 5, right? And then I take g of 5, which is 5 squared plus 2 times 5 plus 1. So I have 25 plus 10 plus 1, which is 36. So you have to do that also. Utan, you good? Okay. Is there anything that we did not cover? Do you know how to tell if two functions are inverses of each other? Okay, you know how to find the inverse? You know how to graph a line and its inverse? Using slope and y-intercept?
Can we do one of those?
Yep.
We do another time.
Yep. Okay, so
We do like a half one.
a half one.
Yeah.
Oh, well,
Is that what?
I was gonna do a line. You'll
Oh.
have like, they'll have like this. You'll have f of x equals 3x plus 1, okay? So I wanna find the inverse. I wanna take y equals 3x plus 1, and then I wanna go x equals 3y plus 1. So subtract 1 from both sides, I get x minus 1 equals 3y. And when I divide by 3, I like to separate it, okay? So I like to write it as 1/3 y, 1/3 x minus 1/3. I divide both of them by that. So my inverse is 1/3 x minus 1/3. Do you understand that, Greeley?
Mhm.
Okay, so when I graph it, I'm gonna graph it in red. When I graph it, I graph the original. This one, it has a y-intercept of 1 and a slope of 3, correct? 3 over 1, so 1, 2, 3 over 1. Right? So it looks like this. Now, instead of graphing this one, because it has a fraction in it, that's the y-intercept, all I gotta do is take these 2 points and turn them and reverse them, right? So this is 0, 1, right? So I'm gonna go 1, 0, and this is 1, 4, so I'm gonna go 4, 1. And it looks like this. Did you catch that?
Okay, so how did you find where?
Did you get all this?
Yeah.
Okay,
Well, how did you know to put it at the 1?
okay. See this one right here? This is the y-intercept, right? That touches the y-axis at 1, right? This is my slope, which is really 3 over 1, right?
Mm-hmm.
So I go rise, 1, 2, 3 over run, positive, right?
So what's all the rest is? Oh,
Okay,
that's to get the
that's
inverse.
the inverse.
Oh.
Instead of graphing this and, doing a negative 1/3 and then up 1, I just flip these 2 points around.
So like, do you have to do all that other stuff?
Yeah, because it'll ask for the inverse,
Okay.
and then it'll ask you to graph both of them.
Okay.
Yep.
So how is it possible that you got whole numbers on like the inverse if you have a negative 1/3?
Well, that's
Why?
because I chose the points, and the points are whole numbers. I could have chosen a fraction. See, it goes through there, right there, a negative 1/3. But that's,
I see.
that would be terrible to do,
I
you
see.
know? Yep. Okay. Any other questions? All right. Right. We'll have a test tomorrow then.